Thank you very much for presentation. Dear Chair, dear ladies and gentlemen, good afternoon. It's rather difficult after dinner to sit here and not to sleep. So I'll try to be quick. And let me start with the presentation, plasma processing of fossil fuels. As you can see, that is collaborative work between Combustion Problems Institute and Research Institute of Experimental and Theoretical Physics. Both of these institutes are from Almaty, Kazakhstan. That is a short review of our works which we do in Almaty, and our group works with plasma processing, as it is seen from the title of the presentation. And the first slide, as you can see, also is about fuel. And here you can see that reserves of fossil fuels worldwide, the main fuel is coal. So we work mainly with coal. And also you can see this slogan, it is not the use of coal, but how the coal is used, that must be the focus of the action. This is a really very good slogan, I think, because the coal is one of the main resources in the world. So we work with plasma, as I said, and that is examples of plasma fuel systems which we designed. There are three kinds of plasma fuel systems. That is direct flow plasma fuel systems, and it is based on usual direct flow burner, pulverized coal burner, and equipped with plasmatron. That is the second type of plasma fuel systems, is vortex plasma fuel systems, and it is again designed on the basis of vortex pulverized coal burner equipped with plasma torch. And also direct flow plasma fuel system, that is a combined plasma generator. Here you can see three electrodes. Between them we light an arc. And also in this volume we entered powder of coal or any other fuel, and have gasification process or processing process inside of this volume. So here you can see basic principles of the plasma fuel systems technology. These two figures you can see about thermochemical treatment of coal in plasma fuel systems, which were based on the burners for the boilers. In this plasma fuel systems we have a rich coal mixture, about 0.6 kilogram of coal per kilogram of air. For example, you can see this system, and when we have processing this fuel inside of the plasma fuel systems, we can have such gaseous phase inside of this PFS. So the main parts of this gas is CO and H2, and of course there is a nitrogen over there because it is a partial gasification of coal inside of air. And that is a mineral part of coal in condensed phase. As about gasification process in plasma fuel system, we have a rather different mixture. Here you can see composition of coal with water steam. In this case we have no nitrogen, or almost have no nitrogen inside of the gaseous phase, but the main part of that is synthesis gas H2 and CO. And also you can see that carbon goes to the gaseous phase quite quickly, and we have complete gasification of this coal. So we will speak about plasma fuel systems for the startup of the boilers first. And here you can see just dimensions of not very big boiler. This boiler is 42 ton per hour steam productivity, and here you can see these dimensions about 30 meters high, 14 meters wide. So that is a rather big volume inside of this furnace. And conventionally, to start up such kind of boilers, such kind of furnace, we need a huge amount of high reactive fuel. For example, fuel oil or gas, natural gas. Here you can see just traditional process of combustion such a fuel inside of these boilers, and we need a lot of hours to incinerate this fuel inside of this furnace just to warm up the internal surface of this boiler and the whole volume, just to have possibility to ignite coal inside of this pulverized coal furnace. And for different boilers, we have we need different quantity of fuel oil for the process of startup. Here in the table you can see this quantity of fuel oil. For example, for small boilers we have not much fuel oil, but for big, of course, we have a lot of fuel oil. And I just want to add that in our country, in former Soviet Union countries, we have not very new boilers, and we need a lot of startups during the months. More than at least every 1 month we have to start up the boiler. But usually, because the equipment is not very new, these startups quite more often, up to 48 and more startups during the year. So you can understand that the huge amount of fuel oil we need for startup of these boilers. So, as you can see here, plasma torch is the main element of plasma fuel system. What is plasma torch? That is rather simple equipment. 2 electrodes, anode and cathode. Between them we light an arc and blow in air. As a result, we have a high temperature flame inside of this and the exit of this plasma torch. Here you can see just a scheme of the plasma torch. And that is a photo of testing of plasma torch for industrial application. Here you can see the flame from plasma torch. The temperature in the exit of the plasma torch is about 5,000 degrees centigrade. And that is an laboratory plasma fuel systems which was installed in the Combustion Problems Institute, in the stand of this institute. Here you can see plasma torch, and that is just direct flow plasma fuel system. Looks like usual burner equipped with plasma torch. Here we used plasma torch power 100 kilowatt, and consumption of coal through this plasma fuel systems was 1 ton per hour. measured temperature of the flame in the exit of the plasma fuel systems was 1180 degrees centigrade. So we can use these plasma fuel systems instead of fuel oil nozzles for startup, for the process of startup of the boilers. Here you can see the flame inside of the furnace of such boiler, which you saw in the very beginning. And the temperature of this flame was measured, and you can see that the temperature was a little more than 1000 degrees centigrade. So using this flame, we can warm up the volume of this boiler furnace, and the process of startup will be we can do without use of fuel oil. So we use coal instead of fuel oil. And some concurrents of this technology. Here you can see a table with comparison of conventional technology, so fuel oil technology and plasma technology. Here you can see the difference, and what interesting investments for thermal power plants just for plasma fuel systems, only not more than 5% from traditional conventional technology, and operating cost is also 3 times less. And also you can see electric power consumption for this technology. In other words, 1 ton of fuel oil equivalent by caloricity can be reduced by replaced by 2 tons of coal. But at the same time, 1 ton of fuel oil equivalent by price is 20 tons of coal. So you can see the difference can be very big. In 1 ton of fuel oil replaced by coal, we have $200 of profit. And what rather interesting, at the same time we have reduction of NOx when plasma torch is working, and at the same time unburned carbon reduced 4 times in comparison with traditional technology. So now about plasma gasification technology and complex processing of fuel. Also you can see here thermodynamic modeling and calculations of the process of complete gasification of coal, and temperature dependence of concentration of organic parts and mineral parts in gaseous phase at complex processing of coal. Complex processing, so we try to process mineral part of coal. Here you can see again in the gaseous phase synthesis gas, CO and H2 main components, and also at high temperature you can see almost all elements which we have in the mineral parts of coal. Here you can see concentration, temperature dependence of concentration in the condensed phase of these components, including carbon, which goes to the gaseous phase, and of course other components from mineral parts of coal. And on the right figure you can see degree of gasification of carbon. This part of this figure shows us that the process of reduction of oxygen of mineral part of coal goes for carbon gasification, and it means that we can reduce these elements to these components to their elements using this oxygen. And okay, thank you. Plasma gasification and complex processing of coal was we use this installation. It is laboratory installation. Here you can see plasma reactor. That is plasma reactor. The arc is lighted between rod and ring electrodes and rotating inside of it in the magnetic field. Here you can see a photo of this reactor in our laboratory. And when we produce experiments, of course, we do material and thermal balance of this installation. And some results of the experiments for different coals. It's Kazakhstan bituminous coal, Canadian Petrochemicals, some Russian brown coal, and Kazakhstan brown coal. Here you can see the ash content of these coals. And main indexes of the solid fuels plasma gasification. Here you can see composition of synthesis gas which we produced, and that is the initial parameters for the experiments. We did complex gasification, complex processing of Kazakhstan brown coal, and here you can see that we managed to reduce up to 47% of the mineral part of coal. Also, we tried, and not only tried, we did plasma processing of uranium, molybdenum, and vanadium containing coals of Kazakhstan, and in the same installation. And here you can see that was utilized by STEP technology. So in these heat exchangers, we could extract uranium, molybdenum, and vanadium. And here in the table, you can see integral parameters of this process for uranium-bearing shale. Also, radiation processing of coal dust on electric accelerator, LU6, activated by an electron beam. Here you see a carousel which was burying pockets with coal, pulverized coal. After that, we use this coal in our installation. And here you can see integral characteristics of plasma hydrogenation of low-grade coal. I just want to say that it was rather profitable. Also, some words about hydrocarbon production by plasma cracking of hydrocarbon gas. We managed to get these figures. And what was very interesting in condensed phase, we found colossal carbon nanotubes. Here you can see the dimensions, but it is really carbon nanotubes. And instead of conclusion, just some parameters and recommendations for these processes which I just showed you. And some just figures, gas composition and the flame of from pulverized fuel system. That is a flame of syngas from high ash Kuchkinsky coal, and produced during gasification of this coal, and so on, different other coals. Okay, thank you very much for your attention.
Thank you very much. Thank you, Dr. Alexandr, for a very interesting presentation. Time for probably one question. Yes.
First of all, not so much a question as a comment, but plasma gasification is becoming more and more prevalent in solid waste management, especially in the UK. Solid waste, household waste and so on. Yes. Yes, okay. But my question is this: how did you measure those flame temperatures? How did you measure the flame temperatures?
We use just infrared pyrometer for measuring this as you saw, that temperature is not very high. That is not just plasma temperature, that is a temperature of combustion. So that is not very big problem in it. But to measure temperature in plasma, that's more really problematic.
One more question. No? Okay, thank you.
Thank you.